Hello everyone, this is Professor Robert Solis. Welcome to our next video lesson. We're still talking about functions, and specifically I'm going to apply functions to help me solve this problem, the water tower project, which is the ability to give the user an opportunity to enter 3 house locations, and then we want to find the best location for the water tower such that the pipe, which are represented by these lines, yields the least amount of distance. And so I definitely am going to be using the distance equation to solve this problem. The houses must be located at the intersection of a Cartesian coordinate. So in other words, they have to be whole number values, right? I can't put this house at 2.1 and 3.4. No, it has to be on an actual intersection within our Cartesian coordinate, and the same thing with the water tower. So what I'm going to do is I'm just going to place the water tower here, then here, then here, then here, and I'm constantly determining what that maximum value is. So I'm going to give you this Excel spreadsheet that basically does that for you. Based on these house locations, where should that water tower be? And so if the house was located at 1, 2, 7, 9, and 9, 1 for these 3 houses, then this right here is telling me that should be the best location for the house, because notice that it yields the least amount of distance. This says 14.73. Everything else is larger, and I want the smallest distance because linear pipe at Home Depot is expensive. Galvanized pipe per linear foot is expensive, and I want to spend the least amount of money, so that means buying the smallest distance possible. All right, so then we're going to create a Visual Studio, a Visual C++ program, and so I'm thinking let's go ahead and type in the function prototypes. Well, for sure, I'm going to use the distance equation. So I'll say double, and I'll say calc distance, and you're going to give me x1. You're also going to give me y1. You're going to give me x2. You're going to give me y2. So this is a function that I can call that will calculate the distance. Let's say that I also want to get the user input from the user. So I'll just simply say void get user input. And in terms of using this program, again, I'm going to need the values for x1, the values for y1, the values for x2, and the values for y2. Now, here's what I'm going to do that's a little bit different. I'm going to pass these parameters by reference. So what I'll do over here is I'll put an ampersand before or after that word int. Let me copy. I'm going to do the same thing for all of these. So remember, we've spoken about passing by value. Passing by value means you're making a clone of the value that you're going to pass. You keep the original, you send the copy. Therefore, if the copy is manipulated, no big deal, you have the original. Here, when you have those ampersands, this is the address of operator. What that means is you're passing the original value. So it's like me not cloning a Frisbee. I throw it, you have the original Frisbee. I did not clone it. Anything that you change with that original obviously is going to change when I get access to that Frisbee again. Right? So these are being sent by reference, whereas on the top these are being passed by value, which means copy and paste. Okay? And so the goal of get user input is just to ask the user, what is the x-axis value, enter the y-axis value for house 1, house 2, house 3, so forth and so on. Okay. Now, I think I'm also going to create a minimum function. But see, we have a minimum function called min. We can use that. You know how we have sqrt for square root, we have pow for exponents. There is min and there is max, but it only receives 2 values. So we want to create our own personal min function that you call it. You can send 3 values. It'll return the minimum of those 3. So I think what I'll do is I'll just simply say, okay, so this guy over here is going to be int, and what happens is we'll call this get minimum, and you send it x1, x. Let's see here. For minimum. No, you just send it 3 values. Okay, so how about value 1? Because I don't want to say x1, x2, x3, y1, y2, right? Because I don't know if you're sending me x or y. You're sending me values. So I'll just simply say value 1, value 2, and value 3. Okay. You send me 3 values, I'll send you back the smallest of the 3. And I want to do the same thing for maximum. So I'll say get maximum. Once again, int value 1, int value 2, int value 3. You send me 3 values, and I'll send you the largest of those 3, because we're going to need that functionality. Let's see here. So the next thing we're going to want to do is we're going to want to move the tower from one point to the next point to try to determine the total distance for each of the different houses, and then we're going to want to find out what that minimum distance is. So why don't I go ahead and do that? Let's say that I want to find out what that total distance is. And so I think what I'll do is I'll say you're going to return to me a double. And let me see here. I want you to calculate the minimum distance. Calculate the minimum distance. Now, in order for you to do your job of determining what that minimum distance is, you're going to need to know the house locations. And also, yeah, I think that's it, actually. You just need the house locations, and then I'll determine where the tower should go, and you return what that distance is. Okay, so let's do this. We'll say you need to know where x1 is, where y1 is. You need to know where x2 is, and y2. Finally, you need to know where x3 is, and where y3 is. Now, of course, those are the house locations, right? Oops, sorry, y3. x3. There we go. Save my work. All right, so another thing I want to do is wherever that tower ends up being that yields the minimum distance, I really also need to know where is that x and y axis. Let me switch back over here to my document so I can show you what I'm talking about. Like, if it ends up that the tower should be here, well, it looks like that's at x-axis 4 and y-axis 7. I need to know that. Where should I put this tower? I mean, so you gave me the total minimum distance, but where does the tower go? So I do need to know that information. So maybe what I'll do is I'll add to this, and I'll say int, comma, int, ampersand. So I'm going to be passing this by value. So I'll say x tower location, comma, int y tower location. Right? And the reason why I have that being sent to me, or the reason why I'm passing that by reference, is because this can only return one thing, right? Functions can only return one thing. So in this case, this function is going to return the minimum distance. But I really do need to know what those 2 values are that yielded that minimum distance. Well, if I pass these by reference, so in other words, when I pass the tower location, inside this function, when I assign what that value is and what this value is, then I don't have to pass these because I'm sending the original. You change the original, I know what that value is. All I have to do is look at the original. So that's a strategy of how I can change or how I can get the value for the X tower and the Y tower location. I just simply pass them by reference, especially with the limitation that functions only send back one item. Okay. And then maybe I should have one last thing, like maybe like a function that takes care of the output, because the output should say something like the tower should be placed at parens whatever the x-axis is, comma whatever the y-axis is, close it, because it yields a minimum distance of, something like that. So what I forgot to do is I forgot to include a string library. So we'll say string over here. That will allow me to return a string. Generate output statement, say for example. All right, well, for this output statement, what do I need? I need the point of where the water tower is. So we'll say X tower location, Y tower location, and I think I may need the distance because I want to say the tower should be placed at this x-axis, this y-axis, to yield a total distance of. So I better go ahead and send the distance. So we'll say total. How about this total pipe length? That's really what I'm trying to determine. What's the total pipe length? Okay, so as you can see here, we have a number of functions here. We have a lot of function definitions to create, but by doing this, you are in essence creating a hammer, a screwdriver, a wrench, and then guess what? You get to use these tools over and over and over again. We're going to create this one time, and then we can call upon it time and again to use these tools. All right, let me go ahead and copy all of these. In fact, I'll go ahead and copy the comment as well, because I'm going to change this to from prototypes to definitions. I'm going to get rid of all these semicolons and turn them into open and close curly braces. So I can Control C, go all the way to the bottom, enter, Control V as in Victor. Get rid of all those semicolons, turn them into open and closed curly braces, because now we are in the function definitions location. So this guy over here. And then finally, function definitions. Right. So get rid of the semicolons, replace those with curly braces, and now you have function definitions, where we're going to now go into the details of what these functions actually do. Well, let me start with an easy one right here called calc distance. All right, you'll recall from the handout that the distance equation is the square root of this to the second power plus this to the second power. So you can see that the outermost mathematical function that we have to deal with is square root. So what I'll do is I'll just simply say, okay, what am I going to do? Well, first of all, I'm going to return something to you. I'm going to return to you the square root, SQRT, open and close parentheses, put a semicolon, put my cursor right back inside of that open and close parentheses. Now, inside of that square root, I have two items that I have to square. I have to square this, and I have to square this. So I'm going to use math.pow for that. So I'm sorry, I shouldn't have said math.pow, just pow, right? I'm going to use pow for that. So power, as you can see here, and then open and close parentheses. I'm going to put my cursor right. Actually, I could do this. I could say that's going to be plus, and then power, open and close parentheses. Let me put my cursor right back inside there, that first one. So it's going to be the difference of what? The x values, x2 minus x1. Okay, so I gave you x2. Oh, great. So x2 minus x1, comma, this is going to be the power. So that's going to be 2.0, because as you can see over here, that's the 2 right there. Okay. So x2 minus x1 to the second power. Put your cursor over here in between the parentheses for the second power, and this one is going to be y2 minus y1, comma 2.0. So what does this thing return? The distance. You give me 2 points, I return the distance between those two. Okay, comments or questions? Now, let's work on this function where it says get user input. Okay, so I'm going to see out. Enter house 1's x-axis. and then the user is going to do that. Now I'm going to take that value and I'm going to cin, I'm going to put that into x1. That notice you sent to me x1 by reference, so when I change x1 here, I'm really also changing it back here in the main function, right? Because it's being sent by reference. And then I'll do the same thing over here. I'll say cout, enter house 1's y-axis. And then of course we're going to put that into y1. So I think all I'll do is I'll just take these 4 lines of code, copy and paste them, and then change the numbers from 1 to 2 and then 2 to 3. So I'll take these guys over here, copy, Control C, Control V, Control V. Now, in Visual Studio, you'll see this button down here. It says INS. So this is the insert button. The opposite of insert is overwrite. Right? So let me just, don't do this, let me just give you a demonstration. What would be great is if I could just simply select that number 1 here, type the number 2, and replace that 1 with the 2. Now I can't do that because I'm in insert mode. I am in insert mode. But if I double click this guy, watch what happens. Now I'm in the OVR, or the overwrite mode. See what happens to the cursor? See how the cursor is blinking as a block? So now I'm going to go over here, hover on top of this, watch what happens when I type in 2. See, it just overwrites it. It doesn't insert it. Over here, I'm going to insert a 2. I'm going to insert a 2, and same thing over here. For these cout and cin statements, this is going to be 3, 3, 3, and 3. So then I will take this insert overwrite mode and turn that back to insert. You know, I just realized something. Get user input, I'm only getting the first point and the second point. What happened to the third point? I didn't do that, so I made a mistake. That's why that red squiggly underline appears for x3 and y3. So I got to fix the prototype and I have to fix the definition. So let me go back over here to where it says get user input. I forgot this, comma, int ampersand x3, comma, int ampersand y3. I'll take these guys and I'm going to copy and paste it. So first of all, please change your get user input. See, you did x1, y1, x2, y2, but I forgot x3, y3. So go ahead and add that, and then don't forget you also have to change that for your function definition. So I'll place my cursor over here and type this, comma, int ampersand x3, comma, int ampersand y3. Make sure you include those. Okay, and that's all that this thing is supposed to do. It's just supposed to get the user input, and so I send it the original x, y, 1, 2, and 3 values or points, and it's just simply going to ask the question, and then we're going to get the answer, or we're going to get the response from the user, and it puts it right directly back into the original variable. All right, now let's work on this function over here called getMinimum. Go back over here. All right, so I had to pause the video lesson for a moment because I was wondering how come I can't use min and max, and I realized why. I thought it was CMath. That's not the library that you want. You want algorithm. With the algorithm library, you can use for min and max. It's what you use. Whoops, sorry, misspelling. Algorithm. There we go. It's the library that's used for this idea of minimum and maximum. You give it 2 values, it returns the smaller of the 2. You give it 2 values, it returns the larger of the 2. So that's what I want to use, and so I've got to include the algorithm over here. See, the reason why I want to use that is because in this particular case, I want to return the smaller of 3 values. So what am I going to return? Well, I'm going to do this substitution method. Watch this. I'll say min, parentheses. Okay, now I got to put 2 values in there. So I'll put val1, comma, min, open and close parentheses, then val2, comma, val3, and then I'll put my semicolon at the very end like this. All right, so the normal use of minimum is like this. I'm going to type something and I'm going to erase it. The normal use would be something like this. Return min of val1 and val2. Okay. That would be the normal usage of the minimum function. It only returns the smaller of the two. So what I've done is a trick. It's a substitution trick. Notice that the first thing, the inner parentheses, is to find the minimum of val1 and val2. Then the smaller of those two is going to be compared with the minimum of val1 and the smaller of this. So it's like a substitution. Find the minimum of these, then compare it to this and find the minimum of those two. So that way, I still use the minimum function. I'm just using it to find the minimum of 3 values. If I wanted to find the minimum of 4 values, I could just simply do this. Let me put a comment over here. I could find the min of val1. Val1, comma, find the min of val2, comma, find the min of val3, comma, val4, close parens, close parens, close parens, right? That would be finding the minimum of 4 values. Again, just using that substitution. Find the smaller of these, now compare it to this, now compare it to this, right? That's all I'm doing. I'm using a trick to find the smallest of 3 values using a function that requires 2 values. Okay. All right. So now, put my laptop here. Let's do the same thing over here for get max. So I'm just simply going to return the max. Ah, nice. There it is. Finds the maximum of. All right. So I'll just simply say val1. Find the max. Open and close parentheses. Put my cursor right back in there. Val2, comma, val3. And I forgot to even spell this correctly, val1. So this function will just simply return the largest of those 3 values that I set to it. Okay. Now we can work on this guy over here, calculate the minimum distance. Okay, well, in order for me to calculate the minimum distance, I'm going to need to go through every single row and column of my Cartesian coordinates. So let me visually describe what I'm talking about. I need to put the water tower here, then here, then here, and so forth and so on. I need to put it at every intersection, and I'm always keeping track of where that is and what's the distance. So I guess the spreadsheet is really a better illustration. When I have these houses at these different locations, when I put the water tower here, it results in 19. When I put the water tower here, it results in a total distance of 17.85, 17.18, so forth and so on. And we're going to completely traverse this entire thing. Okay. Now we're going to do something inefficient, and then we'll make this much more efficient. What I mean by that is, we'll assume that the user can only enter values from 0 to 15. Right? So we'll go for every single row, and then we have every column, 0 through 15. And then the next row is 1, 0 through 15 for the column. Next row is 2, 0 through 15, all the way to row 15. Then we'll be a little bit more intelligent and say, well, based on the house locations, you don't have to scan the entire grid. You just simply look at the house with the one that's at the lowest, or the bottom left-hand corner, and the one that's at the upper right, and now you have your bounds. Right? So your houses are bounded over here. Right now, we're not going to abide by those bounds. We'll just simply scan the entire grid, and let's just say that that's 15. All right, so back over here, calculate the minimum distance. All right, so let's see here. Let me go ahead and type in a comment. We're going to move the tower from intersection to intersection, determining the total distance to each house, and finding that minimum total distance. That's what our goal is. As we move the tower around from location to location, let's find out where that minimum distance is, or what that minimum distance is. Okay, so let me just use a for loop. So I'll say for and I'm going to create a counter called row. And again, I said let's make it so that we're starting at 0 as long as that row is less than or equal to 15, because I'm hard coding, which is a no-no. I'm just doing this right now so that we can get the concept. Then I'll fix my maybe not logical error, but not necessarily the wisest approach to hard code like this. I'm just doing it now so we can understand the concept. I have a grid of 15 by 15. The houses are in that grid. Where should the water tower go? So as long as the row is less than or equal to 15, and then of course row plus plus. All right. Nested within there is another for statement. And I'm going to create another counter called column. And again, I'm starting column at 0. As long as that column is less than or equal to 15, I know I'm hard coding. I'm just doing this right now. I'm going to come back and I'm going to change that. All right. So the first thing that I'm going to have to do is to get the total distance from each house to this new tower location. Where is the tower located? Well, at first it's at column 0, row 0. We're moving the tower right here at 0, 0. Then we're going to move the tower to 0, 1. And then x-axis, y-axis. So 0, 0, and then 1, 0, 2, 0, 3, 0, 4, 0. We are moving the tower along that row, and each time we're going to have to calculate that distance. All right. Well, so what is that? What is that total distance going to be? So you know what I should have done? I should have created a variable, a temporary variable called distance. So I think what I'm going to do is I'll go over here, and I'll just simply say int, or I'm sorry, not int, double, and total distance. That's really what I'm trying to calculate, what the total distance is. All right, so get the total distance from each house to this new tower location. All right, so total distance. Actually, you know what I should have done? Because it's inside here, I should have set that to 0. Otherwise, C++ will complain that I never gave this an initial value. So I'll set that to 0. Then I'll say the total distance is what? Okay, well, the total distance is going to be from house 1 to the tower, from house 2 to the tower, from house 3 to the tower, right? So from house 1 to the tower, house 2 to the tower, house 3 to the tower. I add those 3 distances, and that is going to give me my total distance. I have a function. Check this out. Let me scroll up a little bit. I have a function called calcDistance. So if I give it 2 points, it's going to return to me the distance. So I'm going to use calcDistance. So over here, let's call calcDistance parens. It's now saying to me, you have got to give me 4 values. Give me 0.1 and 0.2. Okay, well, let's say the first point is going to be the tower location. Well, I've got that. That's my row and my column. Oh, I'm sorry, I have to do this the other way because the column represents the x-axis. The row represents the y-axis, right? So rows go like this. They start down here. This is row 1, row 2, row 3. That's y-axis. And then the columns, they start from here, then they go from left to right. So that's really the x-axis. So I'm got to be careful about that. Comma, it looks like I need to now give it the house. Well, look what I sent to you. I sent you x1, y1, x2, y2, x3, y. I sent to you the house locations. So let's compare this to the house, which is at x1, comma, y1. Now I'm not done. I shouldn't put that semicolon there. This is the distance from a house to the tower. Does that make sense? Now I have to add to that the distance from the second house to the tower. So once again, calculate distance from where the tower is located to where the second house is located. Plus, okay, so this is the distance from the tower to house 1, from the tower to house 2. Now I have to do it from the tower to house 3. So calculate distance from the tower to house 3, which is x3, y3. So this is going to determine, what does it say above? The total distance from each of the 3 houses to the tower. Comments or questions? Yes?
When just thinking about the portability of your code, is there ever any issue as far as character count per line?
No.
Okay.
No. I'm trying to think for every platform that I know. There's no issue in terms of the number of characters per line.
Okay.
Yeah. I mean, assuming that you are working with a console-based platform. If you're working with a graphical user interface, then that could possibly be the case. Like, the screen real estate on a laptop is much greater than the screen real estate on an Android phone, say, for example. So then maybe that would be an issue.
Yeah.
But from the perspective of a console application, which is what we're creating, no.
You said this is considered hard coding.
Yeah.
So what would be the other?
The other way would be to create a variable.
Oh.
So over here, create a variable for like the maximum house location, and then I put that instead of 15. The 0, that's not hard coding. We got to start from somewhere.
Oh, because the other one will be like defining everything.
Yes, yes. Actually, I shouldn't have said that. I shouldn't be so dogmatic here. That 0 may not necessarily be the best location. For example, if these are the locations of the houses, clearly the x-axis should start at 1, the y-axis should start at 1, because my bottom left corner is this guy right here. Would you agree that that touches this house, that touches this house? That's my bottom left corner. How about my top right corner? That would be this point right here, because my highest house is at row 9, and my house that's furthest to the right is at column 9. So these are the points that I would get. Go from 1, 1 to 9, 9. Now, we're assuming that we have a grid of 15 by 15, so we're going to go through that entire grid. But based on the house locations, maybe that's not the most efficient way to do it. That's why we don't hard code.
If the question for this particular program was more so what is the distance between the house and the tower, could you still do that, or wouldn't that mess up, I guess, your calculation as far as where the house lies in comparison to the tower on the grid?
So I want to make sure I understand your question. You're asking, what if you just wanted to determine the distance between a house and the tower?
Well, okay, so for this program, it makes sense because they're all starting outside of I guess the one.
Yeah, the tower is outside of the triangle formed by the 3 houses.
Yeah, yeah.
Because we're going to go through every row and column.
Yeah.
Okay.
So if this were really anything other than what we're doing right now, essentially, I guess the question I'm trying to ask is, by taking away that outer row, essentially, is that messing up any of our calculations if we were having to do anything besides this?
No, because you're just you're restricting your starting and your ending point. So it's still calculating distances without having to necessarily increase your outer bounds. If we increase the outer bounds, all we're doing is increasing processing time. It's taking a little bit longer. I don't know what, milliseconds, nanoseconds. It's taking a little bit longer to solve the problem. So it certainly isn't it's not an efficient or elegant way to approach this problem. But in the big scheme of things, going from 1 to 9 as opposed to going from 0 to 15, it's really not going to be that big of a deal. So the solution will still be the same. It'll still come out the same. All right, so now I go over here. And let me type in a comment. If this new distance is smaller than the previous smallest distance, then we want to remember this tower location. Because the tower that's located at this particular location yields a smallest distance so far. So I want to remember that. That's my goal, to get the smallest distance. Okay. So how do I do that? All right. Well, it looks like I'm going to have to create, some sort of a minimum distance. Now, what I'm about to do is not elegant. I'm going to give you the non-elegant approach, and then we'll come back and we'll do a more elegant approach, just so that we can understand how to make this problem as simple as possible. Let me go ahead and create a minimum distance, a minimum total distance. And what am I going to do? I'm going to set this thing to 2 billion. 2. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. So let me see, because that's 100, that's 1,000, that's million, so therefore that's billion. Okay. Because obviously that's a huge number. When I compare the distance of the tower, when I move the tower over here to the 3 houses, I think you will agree that number is going to be smaller than 2 billion, right? So that number being smaller than 2 billion, it is guaranteed to go inside of this if statement. If the total distance is less than the min total distance, if that's the case, then I want to keep track of this tower location. Now, how do I do that? Well, notice that I sent to you, by reference, X tower location and Y tower location. So the X tower location, that's the original value that I'm looking at, is going to be whatever the column is. And the Y tower location, that's going to be whatever the row is. And now, check this out. My minimum total distance now becomes what I just solved, this total distance. That's my new minimum total distance. So when I come back to this comparison again, I'm going to now have a new value that I can compare it to. So I think you can see I don't like this approach. This is not elegant because 2 billion is relative. What if I was, I mean, what am I talking about? 2 billion millimeters, 2 billion inches, 2 billion feet. Maybe in this context, I'm talking about linear foot because that's what I introduced this problem as, right? But still, you can see that this is not an elegant approach. It works because I'm picking a number so big that guaranteed when I make my first comparison, I'm going to establish a new minimum total distance. But we've got to come up with a better idea later on, okay? So we'll leave this for the time being. I think this at least helps you understand that guaranteed this if statement the first time around is going to be true so that we can establish what our new minimum total distance is, and then every other comparison now gets compared to that particular tower location. So comments or questions about this? All right, so what does this thing do? It goes through every single row, and within every single row it goes through the columns, calculating the total distance as I move the tower from location to location. So I'm moving the tower here, 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 and I'm calculating the total distance. I take that total distance and I ask a question. Is that new total distance based on the new location of the tower smaller than the previous total distance of when the tower was located at another location? Because if it is, I need to remember that new tower location. And by the way, what was the total distance that was established by that? We keep on doing this over and over and over again. When we are done, then all I'm going to do is return the minimum total distance. Because that's what this thing does, see? It calculates the minimum total distance. So when you're done with this looping structure, I return to you the minimum total distance. But notice also the trick that I used by passing these two by reference. When this changes here, it changes for the original calling function because I sent you the original. Here's copy, copy, copy. Here I'm passing these two by reference. You're changing the original. So it's almost as if you're really returning three things. You're returning this, you're returning this, and returning this. I mean, you could think of it that way. That's the beauty of pass by reference in this context. Okay. Comments or questions? I think we have one. We haven't even done anything with the main program. We're just building our tools. We're building the screwdriver, the wrench, the hammer. Then once everything is built, your job is going to be so easy because you have these tools that you've created. Let's now do this guy over here. generate some sort of an output statement. And it looks like I give to you the house location and I give you the total pipe. So what are we going to return? We are going to return, actually I could do this. I could create a string called output, set that to nothing. I don't have to do it this way. I could just simply directly return. I'm just breaking it up so it makes readable sense to you. So what is this going to say? The tower should be placed at parentheses. All right, I'm going to take this and I'm going to concatenate that with whatever the whatever the tower location is for the x and for the y-axis. Now, this is an integer that you sent me. I have to do x tower dot. I'm sorry, x tower to string. Oh, sorry, I did it backwards. To underscore string, there it is, and then x tower location. Right, this is an integer. I am concatenating it with a string, so I have to use the toString function. What am I going to concatenate that with? I'm going to concatenate that with a comma, and then I'm going to concatenate that with whatever the y tower location is, so to underscore string with y tower location. I'm going to concatenate that with a closing parentheses. So closing parentheses. And then finally, semicolon. See, this is what I'm trying to, let me just type a comment here. This is what I'm trying to create. The tower should be placed at 1, 2. That's what I'm trying to generate, a statement like that. And so those are the different components. See, this semicolon is that right there. This number right here is that number 2. This comma is this guy right here. This number is the number 1. And then this string, the tower should be placed at, well, that's this entire part right here. Right. So I'm just trying to develop a string in such a way as the user feels like they're talking to the program, right? Someone is talking to them. All right, well, once I have this output statement, then I just simply say return output, right? That's what this thing does. It generates an output statement. And so I'm just simply going to return the string, and then I'll say C out, whatever the response was. Save my work. Okay. Comments or questions? Yes.
We only talked about the tower location and then that was it, right?
Oh yeah, you're right. I forgot the total pipe distance. The tower should be placed at number comma number to yield a total distance of, and then we'll do that. Yeah, good eye. Space to yield a total. Actually, it's not total distance in this case. In this context, it's really total length, total pipe length of, and then I want to indicate what that is. So I'll just simply say toString, to underscore string, and then whatever that total pipe distance is. Now over here, let me just look over here. It says over here that I can send a long, an unsigned, a long, a float. I can send a double. Perfect. Well, that's what I intend on giving you. I'm going to give you the total pipe length. Good. Other comments or questions? Okay. Now we are finally ready to use the tools that we've created. So I'm going to split the screen. See this guy up here? Drag that, split the screen. I want to go over here to remind me, these are all my function prototypes. So let me just put that right there. These are my function prototypes that I can use. And let me go back to my main program. So here we are, the main program. All right, well, I'm going to have to create variables for x1, y1, x2, y2, x3, y3. So I'll just simply say int x1. Now, Some of you have asked me, how come you don't do this? Y1 comma x2. You know, it's just habit. I like splitting them up into individual lines. Do you have to do that? No. You can do comma separation. That's perfectly acceptable. I'm in my main function. Copy, paste, paste. Overwrite, change those to 2's, change these to 3's. Take away, overwrite. All right, so I have my house locations. I'm just looking over here, so it looks like with these functions I send it house locations. Look at this. I also need to keep track of the tower location in my main function as well. So what I'll do is I'll say x tower location and y tower location. Now, you see over here that it says x1, y1, x2, y2, but that's not the same thing as these x1s and y1s, right? These are the x1s and y1s that belong to this. These are the x1s and y1s that belong to this. In other words, these variables are local to the main function. These variables are local to this function. Even though they look exactly the same, they're not the same. You and I go to two different McDonald's. You order hot chocolate, I order hot chocolate. The hot chocolate is the same thing. It's the same cup, the same formula, the same chemical formula. It's exactly the same, but obviously the hot chocolate in your hand is not the hot chocolate in my hand. That's exactly the analogy here. This hot chocolate is not the same thing as this hot chocolate. It's hot chocolate. It's just that it's yours. It's your hot chocolate. This is my hot chocolate. Okay? All right, so I'm looking over here. So I definitely have to give it the location. I give it the location of the tower. Oh, it looks like I also have to keep track of the total pipe length, and it looks like that's a double. So I'll just simply do this over here. We'll say double total pipe length. I could have called this total pipe length parameter over here. But again, you know the idea that this total pipe length belongs to main, this total pipe length belongs to this. I'm just trying to think of, okay, what values do I need to hold so that I can send them to these functions because they need them. All right, I think I've got all my declarations. So now, over here, let's get the user input. Hey, wait a minute. Get user input. Beautiful. All I have to do is call that, okay? Get user input. Do you need something? Oh, yes. You need x1, y1, x2, y2, x3, y3. Okay, so x1, y1, x2, y2, x3, y3. And check this out. This is a void function, right? Get user, it's a void function, so it doesn't return anything. It's going to ask the user, remember, we worked on that program. It's going to ask the user for the values, and it's going to put it right back in because I'm passing it by reference. I'm giving the original. Imagine I had, let me see, 2, 4, 6. I had 6 Frisbees. I don't clone them. I throw you x1, y1, x2, y2, x3, y3. I have no Frisbees in my hands. When you change the values on those Frisbees, you've changed the originals. That's what I'm saying over here. When you change the values because of that ampersand right there, you've changed the original. So here you go. I'm handing you the original to change. Okay, so that takes care of get user input. Now let's work on calculations. Now in the calculations, we're trying to calculate the minimum distance, of course, right? So let's see over here. Calculate the minimum distance. So go back over here. Here it is, calculate the minimum distance. So I call this, it's going to, oh, this calls calc distance. That was the function calling a function. It calls this, and it's going to return what that minimum distance is. And all I need to do is I need to give it these values over here. Okay, so let me go back over here to, so it's not like I have to call this guy over here because this guy over here is calling it. All right, so over here in the calculations, looks like it returns a double, and so the total pipe length is going to be, and then I'll call this function called calculate minimum distance. And what do I need to send to you? So it's telling me x1, y1, x2, y2, so forth and so on. Okay, so I got to send you x1, comma, y1, x2, y2, x3, y3, comma. What else do I need to send? Oh, by the way, I'm sending it by reference. See that ampersand right there? I need to send you the x tower location and the y tower location. All right, so x tower location, comma, y tower location. All right, and that's it. Isn't that nice? Look how small my main program is. See this? Here's main. Look at that. I call this. I call this. I got the total pipe length. Jeepers, I'm almost done. So now I go over here to the output section, and what am I going to do? Well, I'm going to call this guy over here, generate output statement. So I will see out, and I'm going to call this generate output statement. What do you need? Generate output statement. Well, it looks like you need the X tower location. Okay, I'll give you the X tower location. What else do you need? I need the Y tower location. Okay, I'll give you that. What else do you need? And I need the total pipe length. Well, I got that too. Total pipe length. Oops, sorry, put the semicolon at the very end. And we take away the split. Now we're not done with our program. There's some other issues that we have to deal with, but isn't this amazing? Look how small, I mean, and look at me. Here I am taking all these lines for individual declaration. I could turn that into one line, 2, 3, 4 lines of code for my main program, and I'm done. Why? Because you did the hard work of creating all those functions. Now we can use them. Okay. All right, so let's see what happens when I enter these values. So first of all, let's see what happens based on the house locations over here. So let me just write them down on a piece of paper here. It looks like we have a house that's located at 1, 2. So 1, 2. And the other one is located at x-axis 9, y-axis 1. And the other house is located at 7, 9. So 7, comma 9. So I'm writing this down on a piece of paper. Let me go back to Microsoft Excel. It looks like if a house is located at 1, 2, 7, 9, and 9, 1, 6, 4 should be the location with a minimum pipe distance of 14.73. Let's see if we did it right. So let me go back over here and run the program. Let's see what happens. All right, enter house 1's x-axis. Okay, so that's 1. House 1's y-axis, that's 2. For house 2, that's going to be 9, and then 1. And then for house 3, that's going to be 7, and then 9. So let's see what happens. The tower should be placed at 6, 4. Oh, nice. Let me go back over here. Was that what it was? Was it 6, 4? 6, 4. Oh, look at that. 6, 4. To yield a total pipe length of, okay, let's see what it was. What was the pipe length? 14.73. All right, so in this case, it just said 14.72, and it didn't round up, right? We're displaying all the numbers. And I should have put an endl statement there. So let me clean it up. After you do that, endl. So it goes to the beginning of the next line. Wow, that's pretty cool. And it did it so quickly too. So 1, 2, 9, 1, 7, 9. And there it is. The tower should be placed here to yield the total pipe length of this. So I go to Home Depot and buy 14.72 linear feet of galvanized pipe, and I know that I've got maybe, I'll round it up, like 14.8 for sure. Maybe because there's supposed to be some threading at the end so I can connect pipe. I've got my minimum total pipe length, and I've saved a ton of money as opposed to just buying a huge amount of pipe and guessing. Now there's no guessing, it's exact. All right. When I first did this program years ago, taking Fortran for engineering class, it was so cool that I saw this. You guys are solving a bachelor's level program. This is what I did years ago. Now let's refine our program a little bit here, because we do have some things that I kind of let go just so that we can we can deal with this here. I said over here, start your row at 0 and start and end at 15, right? Well, maybe that's not the most elegant approach, because if the house, we want to find the bottom left-hand location and the top right-hand location, and that's going to decrease our bounds from 0, 0, 15, 15 to, in this case, say for example, 1, 1 and 9, 9, right? Because it's not necessary for us to consider the water tower out here. That's outside of the square bounds that are created by these three houses, as you can see here, right? So maybe I better get the minimum of all these houses. Nope, nope. Yes, that's the minimum y-axis. Okay, what's the minimum x-axis? Nope, nope. Yeah, that one has the minimum x-axis. So I've got my 1, 1 point. What's the maximum y-axis? Okay, no, you're not the highest house. Nope, you're not. Yeah, you're the highest house. You're at 9. Okay, what's the maximum x-axis? Okay, no, you're further here to the left. Yeah, you're a little bit more to the right. Ah, you're the one that's the most furthest to the right. So that means that 9, 9 becomes the best the maximum location. Now do you understand why I created get minimum and get maximum? All I have to do is give it the 3 house locations for the x-axis, the 3 house locations for the y-axis. It's going to tell me the minimum for the x, or the minimum for the y, or the maximum for the x, or the maximum for the y, to help me solve this problem of what is the bounding area for my tower to move in. Does that make sense? Comments or questions? Put another way, we're trying to find this square, right? Once we find that square, why should I pick a house over here at 15, or a potential tower location at 15, 15? It's outside the square. You know the tower is going to be inside the square. That's really what the issue is. Okay, so I've got this, and what I'm going to do is I'm going to split the screen. Let me move this over here. And I just want to take a look at get minimum and get maximum. Let me just split the screen so I see those two. And now let me go back over here. And I started it at row is equal to 0. But really, what I need to do, okay, so let me see here. Rows are really the same thing as the y-axis, right? These are rows. So what is the minimum row? What is the row that's all the way in the bottom? Well, here I have get minimum. So I'm going to call get minimum. Open and close parentheses, put my comma back in there. What do you need? You need the 3 house values. So you need y1, comma, y2, comma, y3. The smallest of those, that's where my row begins. Okay, now over here for 15, I need the largest of the rows. So I'll say get maximum, open and close parentheses, and you need the y1, y2, and y3 values and get the largest of those. So instead of going from 0 to 15, you are going to, in this context, if I gave you these house locations, you're now going to go from 1 to 9. Does that make sense? All right, now we'll do the same thing for columns. Now I started the column, and remember columns are up and down, right? So I shouldn't say up and down, sorry. Columns are left and right. Let me show you columns here, just so that's column 1. I'm moving to the right, column 2, column 3, right? So I'm moving to the left and to the right. All right, so where's the minimum x-axis? Well, I can have this function figure it out for me. Get minimum, and I send you x1, comma, x2, comma, x3. These are the 3 x-axis locations for all 3 houses. Get the smallest one. Instead of going all the way to 15, I have get maximum, and I send you once again x1, x2, x3. And so you are going from, instead of going from 0 to 15, which is what we had before, now you're going to be going from 1 to 9 because it's in the bounding area. Now this, I think, is a more elegant approach because you're not wasting time including this huge bound for a tower location that will never exist. The tower has to be inside of a particular bounding box, and I've just established those envelope limits. Okay, well, let's run the program. Let's see what happens. I'm going to run it. I'm going to enter those same values. What do I got? So 1, 2, 9, 1, 7, 9, 6, 4, 14.72. Perfect. Everything's fine. Oh, no big deal, right? Wow, that was impressive, Professor Solis. No big deal. You just simply minimize the bounding box to not include all these outer distances. Okay, and then there's one more issue of elegance that I want to deal with. I didn't like this. You set up a huge value so that guaranteed when you go into this if statement, it's going to be true because your new distance is going to be less than this huge distance that you established. Maybe I shouldn't be so hard on myself. I mean, that's not a bad idea. It works, especially if you know that this maximum is guaranteed to never be achieved. But is there another way that we can solve this? So why don't I just do this? Let me visually explain to you what I'm going to do. You know what? I'm going to put the water tower right here at 0, 0. And then I'm going to get that total distance. So I will solve the distance from the tower to this house, and also this house. And that will be my new maximum total distance. And then I compare everything to that. So what I could do over here is this. Instead of setting it up as a huge number, let me just go ahead and do this. The minimum total distance is going to be this right here. Calculate the distance. Calculate the distance. So I have to make some changes here. Let me just go ahead and copy and paste this. Now it doesn't know what row is and column. You know, I'm just going to put it at the 0, 0 location. The tower is going to be at the 0, 0 location. If the tower is at the 0, 0 location, what is the total distance? And I'm going to call that minimum total distance. Now, when I go over here, when I compare that new total distance with my established minimum total distance, everything is now relative to the house locations entered by the user. So let me stop the code here and show you what I'm talking about. And once again, I'll enter the house locations 1, 2, 9, 1, 7, 9. We're stopping the program here. All right, x1, y1, right? So 1, 2, oh, here it is, right? 1, 2, 9, 1, 7, 3. All right, we step over. So let me see, is it this guy over here? Yeah, step over. Okay, so look at what my minimum distance is. It's 22.69, okay? All right, with that, now I enter into the for statement. Here's another for statement. And now let's get the total distance. All right, the total distance is 19. Is 19 less than my minimum distance? Is 19 less than 22.6? Yes, it is. So guess what my minimum distance now becomes? It becomes the new 19 that I just solved for. And so now, let me stop the program. So now you can see that the approach is, who cares about, I shouldn't say who cares, rather, you don't have to necessarily set this to an arbitrarily large number. Now we can, for a matter of fact, set this to a number that's on our Cartesian coordinate. It establishes a value that's large enough that can be compared, and then it'll get replaced as we enter into this nested for statement, as we enter into this if statement. It gets replaced with a new total distance. So visually explaining it like this. At this point, this is the 1, 1 location, but I put the tower over here at the 0, 0 location, which resulted that 28 number. Guaranteed, this is going to be my new value that's going to yield a minimum, so it's going to replace that old 28 value. And I think we are done. So this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.